Entry December 31st, 1865, from A Journey to Brazil, by Louis Agassiz. Recorded for LibriVox Coffee Break Collection, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lenny. Entry December 31st, 1865, from A Journey to Brazil, by Louis Agassiz. The palms, as a natural group, stand out among all other plants with remarkable distinctness and individuality. And yet this common character, uniting them so closely as a natural order, does not prevent the most striking difference between various kinds of palms. As a whole, no family of trees is more similar. Generically and specifically, none is more varied, even though other families include a greater number of species. Their differences seem to me to be determined in a great measure by the peculiar arrangement of their leaves. Indeed, palms, with their colossal leaves, few in number, may be considered as ornamental diagrams of the primary laws according to which the leaves of all plants throughout the whole vegetable kingdom are arranged, laws now recognized by the most advanced botanists of the day, and designated by them as phyllotaxis. The simplest arrangement in these mathematics of the vegetable world is that of the grasses, in which the leaves are placed alternately on opposite sides of the stem, thus dividing the space around in equal halves. As the stem of the grasses elongates, these pairs of leaves are found scattered along its length, and it is only in ears or spikes of some genera that we find them growing so compactly on the axis as to form a close head. Of this law of growth the palm known as the bacaba of Pará, Oinocarpus distichius, is an admirable illustration, its leaves being disposed in pairs one above another at the summit of the stem, but in such immediate contact as to form a thick crown. On account of this disposition of the leaves, its appearance is totally different from that of any other palm with which I am acquainted. I do not know any palm in which the leaves are arranged in three directions only, as in the reeds and sedges of our marshes, unless it be the Jacitara desmoncus, whose winding slender stem, however, makes the observation uncertain. An arrangement in 5 different directions is common in all those palms which, when young, have only a cluster of 5 fully developed leaves above the ground, with a spade-like 6th leaf rising from the center. When full grown, they usually exhibit a crown of 10 or 15 leaves and more, divided into tiers of 5, one above the other, but so close together that the whole appears like a rounded head. Sometimes, however, the crown is more open, as in the Maximiliana regia, Inajá, for instance, in which the stem is not very high, and the leaves, always in cycles of 5, spread slightly, so as to form an open vase rising from a slender stem. The açaí, Euterpe edulis, has an 8-leaved arrangement, and has never more than a single cycle of leaves, though it may sometimes have 7 leaves when the first of the old cycle has dropped, before the 9th, with which the new cycle begins, has opened; or 9, if the first leaf of the new cycle, the 9th in number, has opened before the first of the old cycle has dropped. These leaves, of a delicate pale green, are cut into 1,000 leaflets, which tremble in the lightest breeze, and tell you that the air is stirring even when the heat seems breathless. A more elegant and attractive diagram of the phyllotaxis of 3/8 probably does not exist in nature. The common cocoa-nut tree has its leaves arranged according to the fraction of 5/13, but though the crown consists of several cycles of leaves, they do not form a close head, because the older ones become pendent, while the younger are more erect. The pupunha, or peach palm (Guilielma), follows the phyllotaxis of 8/21, but in this instance all the leaves are evenly arched over, so that the whole forms a deep green vault, the more beautiful from the rich color of the foliage. When the heavy cluster of ripe, red fruit hangs under this dark vault, the tree is in its greatest beauty. As the leaves of this palm are not so closely set in the younger specimens as in the older ones, its aspect changes at different stages of growth, the leaves in the younger trees being distributed over a greater length of the trunk, while in the adult taller ones they are more compact. This arrangement is repeated in the javari and tucumã (Astrocarium), but in these the closely set leaves stand erect, broom-like, at the head of the long stalk. In the mucajá (Acrocomia) the leaves are arranged according to the fraction 13/34. Thus, under the same fundamental principle of growth, an infinite variety is introduced among trees of one order by the slight differences in the distribution and constitution of the leaves themselves. In the Musaceae or Scitamineae, the bananas, another order of the same class of plants, a diversity equally remarkable is produced in the same way, namely, by slight modifications of this fundamental law. What can differ more in appearance than the common banana, Ussa paradisiaca, with its large simple leaves, so loosely arranged around the stem, so graceful and easy in the movements, and the banana of Madagascar, Ravenala madagascariensis, commonly known as the traveller's tree, which, like the bacaba of Pará, has its leaves alternating regularly on opposite sides of the trunk, and so closely packed together as to form an immense flat fan on a colossal stem. Yet in all these plants the arrangement of leaves obeys the same law, which is illustrated with equal distinctness by each one. This mathematical disposition of leaves is thus shown to be compatible with a great variety of essentially different structures, and though the law of phyllotaxis prevails in all plants, being limited neither to class, order, families, genera, nor species, but running in various combinations through the whole kingdom, I believe it can be studied to especial advantage in the group of palms, on account of the prominence of their few large leaves. The most abundant and characteristic palms of the Rio Negro are the javari (Astrocarium javari), the murumuru (Astrocarium murumuru), the uauaçu (Atalea speciosa), the inajá (Maximiliana regia), the bacaba (Oinocarpus bacaba), the paxiúba (Iriartea exoriza), the carana (Mauritia carana), the caranaí (Mauritia horrida), the ubim (Geonoma), and the curuá (Atalea spectabilis). Of these the two latter are the most useful. The remarkable piaçaba (Leopoldinea piaçaba) occurs only far above the junction of the Rio Negro and Rio Branco. We obtained, however, a specimen that had been planted at Itatiaçu. The many small kinds of ubim (Geonoma) and marajá (Bactris), and even the jará (Leopoldinea), are so completely overshadowed by the larger trees that they are only noticed when clustered along the river banks. Buçus (Manicaria), açaís (Euterpe), mucajá (Acrocomia) grow also on the Rio Negro, but it remains to be ascertained whether they are specifically identical with those of the lower Amazons. So peculiar is the aspect of the different species of palms that from the deck of the steamer They can be singled out as easily as the live oaks or pecan nut trees so readily distinguished on the lower course of the Mississippi, or the different kinds of oaks, birches, beeches, or walnut trees which attract observation when sailing along the shores of our northern lakes. It seems, however, impossible to discriminate between all the trees of this wonderful Amazonian forest, partly because they grow in such heterogeneous associations. In the temperate zone we have oak forests, pine forests, birch, beech, and maple woods, the same kinds of trees congregating together on one soil. Not so here. There is the most extraordinary diversity in the combination of plants, and it is a very rare thing to see the soil occupied for any extent by the same kind of tree. A large number of the trees forming these forests are still unknown to science, and yet the Indians, those practical botanists and zoologists, are well acquainted, not only with their external appearance, but also with their various properties. So intimate is their practical knowledge of the natural objects about them, that I believe it would greatly contribute to the progress of science if a systematic record were made of all the information thus scattered through the land, an encyclopedia of the woods, as it were, taken down from the tribes which inhabited them. I think it would be no bad way of collecting, to go from settlement to settlement, sending the Indians out to gather all the plants they know, to dry and label them with the names applied to them in the locality, and writing out, under the heads of these names, all that may thus be ascertained of their medicinal and otherwise useful properties, as well as their botanical character. A critical examination of these collections would at once correct the information thus obtained, especially if the person entrusted with the care of gathering these materials had so much knowledge of botany as would enable him to complete the collections brought in by the Indians, adding to them such parts as might be wanted for a complete systematic description. The specimens ought not to be chosen, however, as they have hitherto been, solely with reference to those parts which are absolutely necessary to identify the species. The collections, to be complete, ought to include the wood, the bark, the roots, and the soft fruits in alcohol. The abundance and variety of timber in the Amazonian valley strikes us with amazement. We long to hear the sawmill busy in these forests, where there are several hundred kinds of woods, admirably suited for construction, as well as for the finest cabinet work, remarkable for the beauty of their grain, for their hardness, for the variety of their tints and their veining, and for their durability. And yet so ignorant are the inhabitants of the value of timber, that when they want a plank they cut down a tree, and chop it to the desired thickness with a hatchet. There are many other vegetable products, besides those already exported from the Amazons, which will one day be poured into the market from its fertile shores. The clearest and purest oils are made from some of the nuts and palm fruits, while many of the palms yield the most admirable fibrous material for cordage, singularly elastic and resistant. Besides its material products, and of these the greater part rot on the ground for want of hands to gather them, the climate and soil are favorable for the growth of sugar, coffee, cocoa, and cotton, and I may add that the spices of the East might be cultivated in the valley of the Amazons as well as in the Dutch possessions of Asia. End of entry December 31st, 1865, from A Journey to Brazil, by Louis Agassiz.